In this video, we will discuss how to use Excel Miner to first identify a good predictive model using linear regression, and then use that model to score some test data. So in this worksheet, I have partitioned data into training, which is our first several observations, and then in validation set. So this is the one on which our model will be tested. And then we will use it to predict the price of this test data set. So this is a data set which we do not know the price of the car, and we'll be building a predictive model to figure out the price on this data set, then test our model on the validation set, and then eventually score or predict the price of this new data set. So I'm gonna just build maybe 3 competing models, and then I will use the exhaustive subset criterion to figure out the best model between these 3 models. So I will go to predict and multiple regression. Our dependent variable is price, so I will move price to my output variable. And let's say I include a bunch of variables. I'll include age, age square. I want to include if the car is metallic color. I want to include mileage, horsepower, cc. Let's include the number of car doors. We can include cylinders. Where the car has ABS brakes. Then I'm going to include if the car is a sports model. And we also want to include fuel type. So in the big data set, we have 3 different fuel types, CNG, diesel, or petrol. So I want to include CNG and diesel, and my default or omitted category then will be petrol. So we have a bunch of X variables, and we want to see if we can predict our price of these cars based on these feature variables. And I do not know what is a good model among them, so I will be using the exhaustive search criteria. So I'll click on next, and here I will click on variable selection, and let's just also have the fitted values and the unstandardized residuals. And we will click on variable selection. Perform variable selection. We will use the best subsets, which is also the exhaustive search criteria, and click on OK. And let's say I want to get, I'll just click on summary reports. I don't want the detailed reports right now. So we will then click on finish. Excel Miner ran our various models. It reports the model that we specified, so it will report our results with all these variables included, and we can see which of them are significant, which of them are not significant. But then here, Excel Miner has also reported for us the various subsets chosen for different number of variables. So again, we will be looking for adjusted R-squares to be high, which is this column, and we want to also look at a malloc C, which is low but close to the number of coefficients that we have. So if I look down this list, and we also want to have a model that has parsimony versus a model which has several variables. So between these, model number 9, or the model with 9 coefficients, seems to be doing the best because it has a very high R-square, adjusted R-square, and it also has a malloc C, which is low and close to the number of observations or coefficients that we have. So we will say that this kind of is our best model. And this model, let's see what this model includes. So what we have here is the intercept, age squared, mileage, horsepower, cc's, doors, with a sports model, and whether the fuel type is diesel. So notice we had 3 categories of our fuel type, CNG, petrol, and diesel. Between those two, it says that the only thing that is probably important for our model is whether the fuel type is diesel. So now if you read the coefficients on diesel, they are with reference to both petrol and CNG. So we can say that compared to petrol and CNG, diesel has a different impact on the prices of these cars. So if I in fact go back to the output, what we see is that, to read this coefficient, this says that if the car is a diesel car, its price is $4,240 more than whether it is petrol, and if it's CNG, it is $642 less than petrol. And but the coefficient on CNG is not statistically significant. So this kind of is a model that we'll be working with. You may be deciding between 3 models. Maybe you want to check this one, and the other model to see which of these actually does better in terms of R-square. So this is just one criteria, that between the malus P and the adjusted R-square, we are going with the model with 9 coefficients. But it may be good to try 2 or 3 different models too. But I'll just show you how to then proceed with one of these models. So if we click on here, choose subset, then what Excel Miner does is it automatically then loads up those 9 coefficients into our dialog box. So we are now predicting price as a function of these 9 variables. And we'll click on next. Now we are still operating within our training and our validation data set. So we want Excel Miner to run the model and then see how it does on the validation set. So I'm going to keep these selected, but just to see the difference, I'm going to click on detailed reports for my validation, and it's just good to get the fitted values and the unsanitized residuals. So I'll click on these two too, and then I'll click on finish. So what we now get is the model that we selected being run on our data set. So again, it's going to run it on the training and validation data set. These are our variables that we included in our new model. It gives us the p-value. So now notice there's one difference in interpreting the coefficient of diesel between this and what we originally got. In the previous model, we had included both diesel and CNG. So when we interpreted this coefficient, we said that having a car with diesel increases the price by $4,300 with respect to petrol. But now our omitted category is both petrol and CNG. So what we will say is that having diesel increases the price by $4,300 compared to both petrol and CNG. So you always interpret the coefficient of this with reference to the omitted category. In this case, we've omitted 2 categories. So this will be the effect of diesel as against petrol and CNG. So now let's look at the output. And the neat thing about this output is that the root mean square error is already given to us by the software. So it tells us that the root mean square error of the validation score is 2,732. What is this? This is actually looking at the validation. So Excel Miner looks at the predicted value, looks at the actual value, and these predicted values are essentially the values that are given by multiplying our regression output coefficients with each of the x variables. So intercept is 1,900 or 19,000, then our age is minus 316.23, and 1.8 is our age squared, for example. So what Excel Miner does is it adds $19,000, then multiplies the output, the coefficient for age, which is minus 316, with the age, and then plus this times our output coefficient h squared and so forth. So this is doing the prediction by hand, and when it does that, it comes up with the value of this. Now this is the predicted value. The actual value of this car was given by this, and this is the residual between the two. So we can then square the residuals. We square all of these residuals. Then we take the average of those. So this is the residuals for the validation set. we will square them, we'll take the average, and then we'll take the square root. So this is essentially what this root mean square error is. So if you were to square the residuals, this is what we would get. So if you have three models that are competing with each other, you would run this exercise for each of these three models and then see which of them gives you the lowest root mean square error. And this is the model that we will now use to basically predict the price for our training set or the test set. So far what we have done is we've identified our best model, and as we said that our best model is the model with the 9 subsets. So what you can do next is, again, go back and click on your best model. I'm going to just click here and click on next. Now this is what we want to do. We want to score new data based on our model. So I'm going to click on in worksheet, and it is wanting us to know which worksheet contains our test data. And our worksheet that contains our test data is called test. So I'm going to just choose this. And we will click on match by name. So what Excel Miner did was it looked at all the variables in our test data and then looked at the variables that we have in our model, and it matches each of these variables to the models that we want. So if you don't click on this, we will have to do the predictions by hand, which also is not very difficult, but this is just a shortcut of using Excel Miner to score the data. So now what Excel Miner will do is it will run our model again that we just ran, and then it will use the coefficients of that model to predict the price for this new data set. So if I click on OK and then click on finish, then let's see what we get. So now Excel Miner has looked at our training the test data set and then given us a predicted value. So if you look at this is 58, 3364, 61343, and then 110. This is nothing but the results from here: 58, 3364, 11, and then so forth. So instead of doing it by hand, which we can do, you will essentially create a new function here, and you will call this function equal to your intercept plus b1. So you'll actually type in the coefficient times the value of age, then plus b2 times the value of this, and then you keep matching up the various outputs with the coefficients. So we will be looking at these coefficients. We can do it by hand, or we can use the score new data function in Excel Miner to essentially do the same thing, and then we will get the predicted values. So this is what I'm interested in from your results, predicted values for prices over here, and you will do that for your example data set also. You'll predict the y hat variable and then turn in the results here. You can do this by hand again, or with a couple of clicks we can do this by Excel Miner. But this is how we essentially use a model to develop or in fact train our model on a data, validate it with the validation set, and then once we're satisfied with the model, use it to predict a new y hat from our test data set.